Students, in previous lesson of scalars and vectors, we learned multiplication of a vector by a real number. Now we will learn another operation of vector algebra, vector addition. As you know, a vector has a direction 2 with magnitude. So addition of two vectors is not simple as addition of two numbers. In order to add two vectors graphically, the tail of one vector is brought at the head or tip of the other vector. Another vector drawn from the tail of first vector to the head of the second vector gives the sum of the two vectors in magnitude and direction. And it is called the resultant of the two given vectors, as you can see in the diagram. Vector r is equal to vector p plus vector q. The resultant vector of two or more vectors is a single vector which produces the same effect as produced by individual vectors together. For vector addition, we have some laws. One is triangle law of vector addition. If two vectors acting at a point simultaneously be represented in magnitude and direction by the two sides of a triangle taken in same order, then their resultant is represented in magnitude and direction by the third side of the triangle taken in opposite order. Here vector r is equal to vector p plus vector q. In given triangle, you can see side AB represents vector p, side BC represents vector q, and their sum, vector r, is represented by side AC. Another law is parallelogram law of vector addition. If two vectors acting simultaneously at a point be represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. See the diagram of parallelogram OACB, in which the adjacent sides OA and OB represent vectors P and Q respectively, and their sum or resultant vector r is represented by the diagonal OC which passes through the point of action O. The general law is polygon law of vector addition. If a number of vectors acting simultaneously at a point be represented in magnitude and direction by the sides of a polygon taken in same order, then their resultant is represented both in magnitude and direction by the closing side of the polygon taken in opposite order. See in the given hexagon, the 5 sides represent vectors A, B, C, D and E, which are acting simultaneously at a point O, and their sum, vector r, is represented by the 6th side, which is the closing side of the hexagon. Polygon law is an extension of triangle law of the vector addition. The parallelogram law of vector addition is very useful in finding the resultant of two vectors in different sections of physics. So we will find the mathematical relations of vector addition by analytical method. As you can see in the diagram, vector P and Q acting at point O are represented by adjacent sides OA and OB respectively. Their sum, vector r, is represented by the diagonal OC. The angle between P and Q is theta, and R makes an angle alpha with P. By geometry, angle CAD is equal to theta. And side AC also represents vector Q. In right angled triangle OCD, OC square is equal to OD square plus CD square, which is equal to OA plus AD whole square plus CD square, since OD is equal to OA plus AD. Therefore, R square is equal to P plus Q cos theta whole square plus Q sin theta whole square. After expansion and simplification, we get R square is equal to P square plus Q square plus 2PQ cos theta, or R is equal to under root P square plus Q square plus 2PQ cos theta. This expression gives the magnitude of the resultant vector R. As tan alpha is equal to CD by OD, which is equal to CD by OA plus AD. Substituting the values of the sides, we get tan alpha is equal to Q sin theta by P plus Q cos theta, or alpha is equal to tan inverse Q sin theta by P plus Q cos theta. This gives the direction of the resultant vector R. Now consider different situations. When theta is equal to 0 degree, that is vectors P and Q acting along same direction, then R is equal to under root P square plus Q square plus 2PQ, since cos 0 degree is equal to 1. Or R is equal to under root P plus Q whole square. Hence R is equal to P plus Q, and tan alpha is equal to 0, which implies that resultant is along the same direction as P and Q. Next situation is when theta is equal to 90 degree, that is vectors P and Q are at right angles to each other. Then R is equal to under root P square plus Q square, and tan alpha is equal to Q by P, since cos 90 degree is equal to 0 and sin 90 degree is equal to 1. Another situation is when theta is equal to 180 degree, that is vectors P and Q are opposite to each other. Then R is equal to under root P square plus Q square plus 2PQ into minus 1, since cos 180 degree is equal to minus 1. So R is equal to under root P square plus Q square minus 2PQ, which is equal to under root P minus Q whole square, and hence R is equal to P minus Q. And tan alpha is equal to 0, which implies that the resultant is in the direction of the larger vector. Let us now see the properties of vector addition with the help of diagrams. Vector addition is commutative, that is vector R is equal to vector A plus vector B, which is also equal to vector B plus vector A. And this you can see in the diagram. Also, vector addition is associative, that is R is equal to A plus B plus C, which is also equal to A plus B plus C, which is clear from given diagrams. After addition, now consider subtraction. In vector algebra also, subtraction is not separate operation. In order to subtract one vector from the other, the direction of one vector is reversed and the negative vector is added to the second vector using same parallelogram law. See in the diagram, two given vectors are A and B. When negative of vector B is added to A, then resultant R is equal to vector A minus vector B. When negative of vector A is added to vector B, then resultant vector R dash is equal to vector B minus vector A. Here you can see vector R dash not equal to vector R. Parallelogram law is also used in finding the relative velocity of an object, which we will discuss later. Okay then, see you in the next class.